All right, so today we're going to do determinants. All right, so we're going to be doing a determinant of a 2 by 2 matrix as well as finding determinants of a 3 by 3 matrix. We are going to find determinant of a 3 by 3 matrix in two different ways. One way is expansion by minors, and the second way is using the diagonal method. All right, so first let's talk about what a square matrix is. So a square matrix is going to be a matrix that has the same number of rows and columns. All right, so same number of rows and columns. And that is kind of small, so let's make that bigger. Where it? Oh, we'll make it a little bit bigger. All right. All right, so square matrix have the same number of rows and columns. So basically it is the same dimensions. All right, it's going to be the same dimensions. So like a 2 by 2, 3 by 3, 4 by 4. Those have same number of rows and columns. All right, so a real number associated with each square matrix is called a determinant. All right, so each matrix is going to have a real number that is associated with it, and that number that is associated with that particular square matrix is going to be called the determinant. All right, so how do we find a determinant? All right, so there is a formula to find the determinant of a 2 by 2 matrix. So basically what you are going to do is you're going to find the difference between the cross products of the elements. All right, so when I say cross products, so think about when you do solving proportions. All right, so you have two fractions that are equal, and if you wanted to solve those proportions, you would cross multiply. All right, so the difference here is there is no equal sign in between those two sets of numbers here. All right, however, what we want to do is we still want to find the cross products. All right, and when we find those cross products, we're going to find the difference between them. All right, so I'm going to multiply A times D. All right, and you always start with the very first element first. All right, minus, and then I would do the product of the other two. So that would be B and C. All right, so that is how you find the determinant of a 2 by 2 matrix. All right, so you find the difference between those cross products. Okay, so let's look at the first example. It says find the determinant of the following matrices. Okay, so for part A, we have the matrix 2, -2, 3, 6. All right, so notice, excuse me. So notice here when we have a matrices are denotated by brackets. All right, the symbol for a determinant, notice they don't have the little brackets here. All right, so it looks like the absolute value sign, except we don't call it absolute value when we talk about matrices. We call it a determinant. All right, but the symbol is just the same. So whenever you see the lines without the bracket pieces on them, that means determinant. All right, so part A wants me to find the determinant of this particular matrix. All right, so again, I'm going to cross multiply. So it's going to be 2 times 6. All right, and then I'm going to subtract the cross product of the other two. So 3 times -2. All right, and then I simplify. So 2 times 6 is 12. And then 3 times -2 is -6. And then if I do 12 minus -6, that becomes a plus. Minus a negative becomes a plus. And so that would become 18. All right, so the determinant of that particular matrix is going to be 18. All right, so let's try another one. All right, so again, let's look at part B. So the matrix they want us to find the determinant of is -4, -2, 6, 3. So again, cross multiply. So I'm going to have -4 times 3. minus, and then I'm going to multiply the other two. 6 times negative 2. All right, and so negative 4 times 3 is negative 12. All right, bring my minus sign. And then I have 6 times negative 2, which is negative 12. And then negative 12 minus a negative. So remember, minus a negative becomes a plus. So negative 12 plus 12 is 0. All right, so how about you go ahead and try example C on your own. Press pause if you need to, just to give yourself a chance to do it before I start to explain it. So go ahead and press pause now. So this is how you should have done C. So I would have done 1 times negative 4 minus 6 times 5 so that would have given me negative 4 minus 30, which is negative 34. So that is what you should have gotten. It's your answer. If you did, very good. Good job. If you didn't, hopefully you see where you made your mistake so that you can correct it for the next time. All right, so find the determinant of a 3x3 matrix. All right, so the first method that we're going to do is expansion by minors. All right, so basically a minor is going to be a smaller matrix that does not include the row and column of the removed matrix. All right, so if we look at this, okay, right here. All right, so the formula, all right, that they have written is going to be the determinant. So this is the 3x3 matrix. All right, so you would take matrix, you would take element A, all right, and then you will multiply it by its minor. All right, and so the minor is going to be what you get left over after you remove the row that contains A and the column that contains A. So if I remove row A, B, and C, all right, I'm left with D, E, F, G, H, J. And then if I remove the column here that contains element A, then I am left here with these two. All right, so, and as you can see, that would be my minor. So that is how you find a minor. It is going to be the matrix that is left over once the row and column of a particular element has been removed. All right, so you would take A, all right, you will multiply it by its minor. Then you would take the difference of B multiplied by its minor, all right, and then you would add C multiplied by its minor. All right, so I'm going to show you next just so how you get those minors. All right, so you only work with the first row, okay? So we're only going to use elements A, B, and C when we make our minors. All right, so we first, of course, start with element A because it's the very first element. So to get the minor of element A, again, I would remove the row that contains A and the column that contains A. All right, so the elements that will be left, I would find the determinant of these 4. All right, then I would go on to matrix B. All right, so not matrix B, I'm sorry, element B. So that would be a subtraction sign. So you would take the difference of element B. And so again, I would erase the row that contains element B as well as the column that contains element B. All right, so the matrix that will be left would be D, G, and F, J. All right, so that would be your 2 row by 2 column matrix as your minor. And then the last one you would do would be C. All right, and so again, you would erase the row that C is on as well as the column. And then that will be the determinant that you will multiply right there. Okay, you will find the determinant of that 2 by 2 matrix there. Okay, so let's look at example 2. So it says find the determinant using expansion by minors. All right, so let's go with the B. I'm going to go with blue because that's how I color coded this one. All right, so A, okay, is going to be -2. So what I would do is I would do -2, okay, times the determinant of, so I would erase the row that 2 is on, as well as the column. All right, and the matrix that is left is 1, 4, 6, and 2. All right, and so that right there is going to be my first number, okay, of my formula. All right, so then the next one. Now I have to do B. All right, so B I had color-coded red. All right, so B is going to be the second element on the first row. So that would be a 1. All right, and it's going to be -1 because that's the formula. So you would subtract, then add. So it would be -1. All right, and then to get the minor, I would erase the first row that B is on. I would also erase the column that B is on. All right, and the matrix that is left is going to be 1, 4, -3, and 2. All right, and then we have green. All right, so let's erase there. All right, so it's going to be plus. All right, so the last one you would add. All right, and so my last element on the first row is 3. All right, so the determinant I would eliminate the row that 3 is on, as well as the column. And it would be 1, 1, -3, and 6. All right, so there is my formula. So now I want to simplify. All right, so what we're going to do is we're going to actually find the determinants of these 2 by 2 matrices. All right, so to find the determinant, remember again, we're going to cross multiply and find the difference. So this would give me 1 times 2 minus 6 times 4. Okay. Then I'm going to move on to the next one. So I will be -1 times, and then I find the determinant of this 2 by 2 matrix. So that will be 1 times 2 minus -3 times 4. Right. And then the last one, so that would be a plus sign, and then it would be 3. And then I find the determinant of that last matrix, which would be 1 times 6 to minus -3 times 1. All right, and so the last thing to do now, simplify some more. So this would be 1 times 2, which is 2, minus 24. All right, minus 1 times 2, which is 2, minus -12. All right, and then we got plus 3 here. And then, so 1 times 6 is 6 minus -3. All right, then we can simplify a little bit more. So that would be -2 times, so 2 minus 24 is negative 22. All right, 2 minus negative 12, that will be plus, so 2 plus 12 is 14. And 3 minus negative 3, so that will be 6 minus negative 3, so 6 plus 3, which is 9. All righty, getting down to the end. So negative 2 times negative 22 is positive 44. Negative 1 times 14 is negative 14. And then 3 times 9 is positive 27. So 44 minus 14. I'll switch to black now. So 44 minus 14 is going to give me 30. And then 30 plus 27 is going to give me 57. All right, so the determinant of that particular 3 by 3 matrix is going to be 57. Now, do you necessarily have to write out all of these steps? No. All right, so you could have really simplified by putting everything into the calculator right here and making sure you put all your brackets and commas correctly. I'm sorry, not brackets and commas, brackets and parentheses correctly, and came out to 57. I just like to break every single step down just to make sure you clearly understand. So, but yeah, you did not have to do each and every step. I just like to show you a clear-cut explanation of how to get to the answer. All right, so that is expansion by minors. All right, so the diagonals method. All right, so find the determinant of a 3 by 3 matrix using the diagonals method. So to do the diagonals method, what you would do is you would take your matrix, right? And so the matrix that they would give us would not have these 2 columns right here, right? So imagine these 2 columns were gone. It would just be this matrix with A, B, C, D, E, F, G, H, and J. All right, so the first thing you are going to do is take your columns, the first 2, and repeat them on the outside. So I want to take the first column and repeat it behind my matrix. And then I'm going to take the second column, okay, and repeat it behind that one. All right, so I'm going to take the first 2 columns, okay, and repeat it behind my matrix. All right, after I do that, all right, I'm going to multiply those diagonals. All right, so I'm going to start with the very first element, which is A, and then I'm going to multiply this diagonal. So that will give me A times E times J. All right, then the next thing I'm going to do is I'm going to multiply the next diagonal. So that's B, F, and G. All right, so I'm going to multiply B, F, and G. All right, and then there's one last full diagonal that has 3 terms, and I'm going to multiply that one as well. So that will be C, D, and H. All right, so once you multiply those 3 diagonals, the next thing for you to do would be to take the sum of them. All right, so this will be one set of diagonals. All right, those are the diagonals that go left to right. All right, so once you find the product of those 3 diagonals, you will find the sum. All right, the next thing you would do is do the diagonals going in the opposite direction. So now I'm going to do the diagonals going from bottom to top. So that will be G, E, C. All right, and then I'm going to do HFA. All right, and then I'm going to do the last one, JDB. All right, so I find the products of those. All right, and again, this is also one group. And once I get those products, I would find the sum of those three. All right, and I would add it together. All right, once I get the sum of both sets, the red set going top to bottom and the blue set going bottom to top, I find the difference. So I would then subtract them. And that's how you find the determinant using the diagonals method. All right, so let's do an example. So let's get my red going here. All right, so of course I'm going to start at the very first element. All right, and I have already recopied those first two columns. So that will be 2, 2, well, negative 2, excuse me. 1, 1, negative 3, negative 3. And then I copy this next column behind it as well. So 1, 1, 6, 1, 1, 6. All right, so after I do my recopying, all right, you start with the very first element. So I'm going to go negative 2 times 1 times 2. All right. And then the next group I will multiply is the 1 times the 4 times the negative 3. All right, and then there's one more group going top to bottom. That would be 3 times 1 times 6. All right, so after I find my products, then I would sum them together. All right, and that is my first group right there. All right, then I'm going to do the bottom to top. So that would be negative 3 times 1 times negative 3. All right, make sure I copy that right. Yep, negative 3 times 1 times 3. All right, and then I'm going to do 6 times 4 times negative 2. All right, and then I would do 2 times 1 times 1. All right, so after I found those products, I would add them together, all right, to get that sum. All right, and then after I do that, the last step is to take the difference in between the two. All right, so let's go ahead and start our calculations. So negative 2 times 1 is negative 2. And then negative 2 times 2 is negative 4. 1 times 4 is 4. 4 times negative 3 is negative 12. All right, and so I am simplifying the signs. Instead of writing plus negative 12, I just wrote negative 12. And then I would do 3 times 1, which is 3. And then 3 times 6, which is 18. Okay. So that is the first set. All right, so let's start simplifying the second set. All right, so the second set, I have negative 3 times 1, which is negative 3. And then negative 3 times 3 is negative 9. 6 times 4 is 24. 24 times negative 2 is negative 48. And again, simplifying the signs, instead of writing plus negative 48, I just wrote minus 48. And then I have 2 times 1, which is 2. All right, and then of course in the middle, that would be a subtraction, because after I found the sums, I would do the difference between the two. All right, so let's simplify a little bit more. So I have negative 4 minus 12, which is negative 16. And then negative 16 plus 18, which is 2. All right, then negative 9 minus 48 would give me 57, negative 57. And then negative 57 plus 2 is negative 55. All right, and again, in the middle is a negative sign. So I'll put this in parentheses since it is negative as well. Okay, so last step, I have 2 minus negative 55. So minus a negative become plus. So 2 plus 55 is 57. And 57 would be my determinant of this particular 3x3 matrix. All right, so that is how you do determinants of a 2x2 matrix as well as 3x3 matrix using both diagonals method and expansion by minors. Thank you so much for watching my video.